machine learning operations. So this is I'm going to go through the application of machine learning operation concepts in our project, which is layer-wise relevance backward propagation, deep transfer learning in tomato diseases. My name is Julia Drake. So first of all, I'll go through what MLOps are. And MLOps, this is a combination of DevOps style automation methods and machine learning best practices focused on the deployment and operation of machine learning models into production systems. So just like agile development, this is just MLOps like brings together the designers or the machine learning engineers, then the data science engineers, and then other stakeholders together into constant improvement of machine learning models, produce like the best machine learning model. So under design, you can have requirements engineering, machine learning use case prioritization, data availability checks. And you can have data engineering, machine learning model engineering, model testing and validation. Then operations can have machine learning model deployment, then continuous integration and continuous development pipelines, then monitoring and triggering. So those are some of the things. Then different machine learning best practices, we have DevOps, which is development operations, continuous integration and continuous development, maturity model, data operations, and all others. So why do we need MLOps? First of all, in our project, we need to use MLOps for model deployment and automation. Since automation saves time, like to build these models, so MLOps emphasizes the automation of model deployment pipelines, enabling rapid deployment and update models into production. Then there is continuous integration. So anytime, this can be on a cloud or it can use GitHub. So every time a new change or something different will be needed to be included into our project, which is tomato detection. So we can use CI/CD pipelines to facilitate the integration of these new data sources, model improvements, and then fixing bugs into the system, allowing faster iteration and improvement of detection models. Then model explainability and interpretability. So no user wants to use like a model which not interpretable and then cannot explain everything. So the only way to do that is to use MLOps. So as machine learning models are deployed in a critical application such as the one we are in, essential to ensure that they are interpretable and explainable so that these users can really see how these models work and then they can really agree with that. Then scalability and resource management. So since this data will be, even the model can be stored on the cloud, can really be able to use these models in different machines like PC, then phones, tablets, all that. Then it can really be easy. Like in case of any loss, this can help. Then collaboration, for us to collaborate together, remember we're using different codes. We don't know what each one of us is going to be using. We have to use MLOps to help us in collaboration and then communication. So these are different MLOps trends and technologies which we're going to use in our project. First is the NSF Ops, which is a file system. So a developer working in a terminal that is in the cloud. So this is a new file system. So you can use GitHub code spaces for coding or AWS Cloud9 for coding. This can work as GitHub so that we can have one terminal we are working with, okay, one space that we are all using, which ensures like speed working and all that. Then there is Kaizen machine learning. With Kaizen, we know it's all about, depends about like constant improvement. So an automated process improvement, automated feature engineering, all that, making everything automated for fast delivery and then constant improvement. Then there is model portability. That is, taking a model built in many different frameworks. This can be Canvas, can be TensorFlow. It can be easily converted to one universal format, which can work on every device. Then edge-based machine learning. So use of machine framework, do a transformation, deploy to many devices. Can be a PC, can be a phone, all that. Then DevOps, set of practices, tools, and culture philosophy that automate, integrate the processes between software development and IT teams. So develop development operations, these are like collaboration, that is development, code, planning, testing. So everyone like sit down together to do that with continuous integration, quality control. And then this is the base of any MLOps, infrastructures, code, all that. Then data ops, that is data plus operation. These are all the operations done on data. Then that is extracting the data, transforming data into variable insights, then discovering like the trends and then access controls in this data, then data governance, that is automation, monitoring and management of any kind of data. For our case, these are gonna be images of plant leaves. Then heavyweight and lightweight. These are just machine learning operation workflows. With heavyweight, this is more sophisticated, does two parts, data-centric and model-centric. Data-centric needs no modeling at all, uses auto machine learning. With model-centric, you create a model, use ML platforms, that is in data labeling, data drift detection, future store. Future store, these are just the different futures that can really control the model registry, model monitoring, and all that. Then with lightweight, this is static and simple. It is small, so you can take something from GitHub, or it can be live on GitHub because it is very small. Then you could use a cloud native build system like Google App Engine, then serve output, then use API. Then hierarchy of data need. DevOps is just the base of everything. Without it, there's no MLOps. Then there is data operations I've talked about. There's platform automation. Then there is MLOps at the top of it. So future stores, model serving, those are under platform automation. Then the journey, that is MLOps maturity model. First, we're gonna establish the experiment environment. Or it's gonna be on GitHub, cloud, or that. Then repeat everything, code repositories to see if this machine learning solution will really work. Then we test if it is reliable. Then we make sure that it's scalable, that is, can work on every device. Then how to protect machine learning against data poisoning. Data poisoning, like this is inserting like an image into this data that won't be really allowed to run on any device. So developers can perform regression testing, data checking, then restricting several users from accessing like different points. Then organizers can perform penetration tests to control that. Then you can also handle data drifts, that is changing different data being fed to the machine learning. You can do this by data cleaning, data enrichment, data validation, regular monitoring, and then data governance to make sure that there is no change in this data being used to test these machine learning models, because that can produce different results. Then different roles of different ML components. Continuous integration, we've seen like in case of any change, we can easily integrate this code or anything or these bugs into the system. Continuous delivery. So every time we have to constantly automatically deploy code changes to the product environment. Then future stores, just storing different futures that are used by these machine learning models, like the plant leaves or that. Then specifiers of the makefile requirements, read, then main.py, and then the license, which shows like the different license on which it's running, configuration, and also the important configurations of this model. Thank you.